Good morning. My name is Beth Dixon, and I am the Math Lab lady and run the Math Lab at Walter State Community College. And this is where we're working out the Math 0030. I don't know why this is 1030. It is the 0030 final review. And we're on page 4 of that review in problem number 14. And these are the evaluate and write the results in scientific notation, and that is the section where we do the computations of working with numbers that are in scientific notation. And this is actually one of my favorite parts. I like to work in scientific notation because it has this nice little thing where we can multiply the numbers and then use our ability to do scientific notation and use our rules for exponents for the scientific notation part. So let's take this first problem here, and we are going to use our calculator for this. We're not going to try to multiply this by hand. And what we do is, in this first problem, we have 4.5 times 10, and there I have to reach and get my glasses. Problems of getting old. 4.5 times 10 to the negative third times 2.3 times 10 to the negative 2. So in this problem, and because there is absolutely no room left on this problem, I'm going to rewrite it over here my whiteboard. 4.5 times 10 to the negative third times 2.3 times 10 to the negative 2. And because there is no addition, this is not a FOIL. This is all multiplication. So multiplication we can rewrite and multiply in any order. So that would be like taking out those time symbols. That's the same as writing this. So that's the same as writing it this way. So I'm going to take the calculator and multiply 4.5 times 2.3, which gives me 10.35, and when I have a 10, that's the base. And what do I do to my exponents? If the base is the same, I add my exponents. So that would be negative 3 plus a negative 2. Now notice that that will give me a negative 5. And the negative exponents work just like anything else. Now the problem is that this is not in correct scientific notation, so I'm going to write it as a number first in normal number and then change it back into scientific notation. That negative 5 says move it 5 places to the left, so that's 1, 2, and I'm going to need some zeros, so I'm going to add some zeros here. So that's 1, 2, 3, 4, 5, and I added too many zeros, but I did that on purpose. And so I get 0.1231035. That's my number. And then to change it back into scientific notation, remember I want one digit in front of the decimal, so that'd be 1, 2, 3, 4. So that's 1.035 times 10 to the negative 4. Some of you may know how to switch the number from this form to this form. If you do, great. I generally rewrite it as a standard notation and then change it back into scientific notation. Let me grab my eraser. If I erased it too quick, remember you can rewind. Okay, our next problem is negative 2.8 times 10 to the 8th times 4.2 times 10 squared. And in this one, I'm not going to take the time to rewrite it because we've already proved that we can just multiply any parts of this that we want. So I'm going to take negative 2.8 and multiply by 4.2. That gives me negative 11.76. And then I can add the exponents on my tens. They share the base, so the base does not change. And then you add the exponents. 8 plus 2 is 10. Then I'm going to change it. Negative 11.76. And I'm going to add a whole bunch of zeros here. And what do? I move it 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm just going to erase those last three. The magic of the whiteboard. So what do we have? We have negative 11, 7, 6, and 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 1, 2, 3, 1, 2, 3. And if we wanted to move it and change it, we would need to move the decimal between the first two ones. So that'd be negative 1.176 times 10. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the 11th. I like these problems because it gives us plenty of practice for changing back and forth to scientific and standard notation. Okay, next problem. 3.2 times 10 to the negative 7th times negative 2.4 times 10 to the 5th. Take the calculator, multiply the numbers. 3.2 times negative 2.4. That gives us negative 7.68. Then we will add the exponents, negative 7 plus 5. Notice that even though I can add negative 7 plus 5 in my head, I do take the time to do that on the calculator because these are a little different because we are adding positive and negative exponents where you may not have done that previously. And so then that gives me negative 2. Notice this one is in standard scientific notation. It's not in standard form, but it is in not standard notation, but it is in correct scientific notation with 1 digit in front of the decimal. So we don't need to change this one back and forth. We could if it asked for it, but the directions said write the results in scientific notation. So this is correct, and we can stop here. Okay, the next three are division, and they actually work the same. 5.2 times 10 to the 7th over 1.5 times 10 to the 4th. So what we can do here is do the 5.2 divided by 1.5 times 10 to the 7th over 10 to the 4th. We can divide that problem up this way. And so I will take 5.2 divided by 1.5, and that gives me 5.2, did I copy that right? 5.2 divided by 1.5, and it gives me an ugly decimal, yuck. I don't know if I like that ugly decimal. I don't like the fraction much better. So I'm just going to write 3.4 6, and I'm going to put a repeating 6 over top of it. Times 10, and what do I do when I divide? I subtract my exponents. So that would be 7 minus 4, which is 3. The nice part is, again, this one is incorrect scientific notation. How do I know it's incorrect scientific notation? It looks like my nail was dirty, but it's not. It is incorrect scientific notation because the 3 is the only digit in front of the decimal. Okay, let's look at the next one. 3.6 times 10 to the negative 5th over 2.4 times 10 to the 3rd. Again, take your calculator and do the arithmetic. 3.6 divided by 2.4 should be 1.5. And then subtract your exponents. And again, be careful here because we are subtracting. It's negative 5 subtract 3. So it's negative 5 subtract 3. And notice that how I wrote that in the calculator. You couldn't see me type those in because I had that too low, but it was negative 5 subtract 3 right here. And that, of course, gives me negative 8. So be very, very careful. Now I sound like Elmer Fudd. Okay, next on the list we have negative 4.8 times 10 to the 5th over 3.6 times 10 to the negative 7th. And so I'm going to take this one and type in negative 4.8 divided by 3.6, and that is a point there. It's hard to see that decimal. And that gives me negative 1 point repeating 3s, and I'm just going to draw a line over that. If your teacher tells you to round, that's what you'll do. I'm not rounding, I'm drawing it repeating because I'm not sure what your teacher will ask you to do. That varies so much teacher to teacher on how many decimal places. So I will leave that for your teacher to decide. And again, it is incorrect scientific notation because there is only one digit in front of the decimal. Then again, we have to subtract our two numbers. That is a 5, a subtract sign, and then the bottom number, which is a negative 7. So that's 5 subtract, and if it helps, you can use parentheses like I did, but even if you don't, and just type in a negative 7, and let me see. There you can see that a little bit better now. 5 and then a negative 7. Notice that I didn't need the parentheses, but if it helps you, 5 subtract a negative 7, it may help you to see that a little bit better. But either case, that would be then 10 to the 12th. Because when you take away a negative, that is the same as adding that positive. Because if you taking away, that's adding it back. Okay, now let's go back. I'm going to erase that out. And let's go to the next problem, number 15. For each, label as a function or not a function and explain your reasoning. Quickly, let's review what a function is. A function means for every input, there is exactly one output. That means that as I look down the input, if I ask what goes with 1, you can only give me one answer. For 1, there is only one answer, a 5. For 2, there is only one answer, a 10. For 3, there is only one answer, a 5. For 4, there is only one output, a 10. Now, it doesn't matter that 1 and 4 share the same answer because they're sharing an output. What we don't want is one input sharing two different outputs. In other words, if I go in and ask you what output goes with 1, I want you to tell me the same answer every time. So letter 15A, number 15A is a function. Let's look at B. For 4, you will always tell me 5. For 3, you will always tell me 5. For 2, you will always tell me 4. For 1, you will always tell me 3. So it is a function. Let's look at C. For 3, you tell me 8. For 2, you tell me 5. But 2, you could tell me 2. So for 2, you could either tell me that the output is 5 or the output is 2. So when the input repeats to 2 different outputs, you have a choice of answering. So if I ask you in letter C, what is the output that goes with 2, you have a choice, and that means that it is not a function. I kind of think of it as a Coke machine, and if I go and push the number 2, I get an option. So sometimes sometimes I don't get what I want, and sometimes I do, or don't get what I expect. And so that's not functioning. So this is not a function. The 3 also causes the problem because sometimes you can answer an 8 and sometimes you can answer a -1. So that's how you tell the difference in a table. For graphs, for the D, E, and F, it is a simple matter of looking at a vertical line test. Because again, we're looking for repeated inputs that give us the same output. In other words, as we look at this, is there a place that there's a vertical line? If I ask you what goes with 1, there's only 1 output. But if I ask you what goes with 5, you could tell me either 5, 0 or 5, 2. So this fails the vertical line test here, and it fails the vertical line test here. So this is not a function. C fails the vertical line test in lots of places, so we'll just say not a function. Excuse me, not C, E. Even with my glasses on, apparently I can't see. And then F, even though it's really strange in curves, it's called a cubic function. It passes that vertical line test no matter how many lines I draw, and you don't have to actually draw them to see that. Most of the time I just hold my pencil up and just say, oh, it's only touching 1 input at a time. And that input has only that 1 output on the graph. And so this F is a function. It passes the vertical line test. Now let's look at G, H, and I, which are a list of ordered pairs. And they work just like a table, except they're not listed as a table, they're listed as ordered pairs. So remember, in this, the first number is your X, the second number is your Y. So that's an X, that's a Y, that's an X, that's a Y, that's an X, that's a Y. So we're looking to see if this X, if I say what goes with 2, you should answer 3. Is there another place where 2 goes with something else? Well, that's a 4, that's a 4, that's a 2. Do they go to the same number? No, because this one goes with a 3 and this one goes with a 1. So is this a function? No, this is not a function. The 4 goes with the 5, and the 4 goes with the 3. The 2 goes with the 3, and the 2 goes with the 1. So it's not functioning. If I ask you what goes with 2, you can give me 2 options, and that makes it not functioning. It's not a function. Okay, let's look at H. There's the X, and again, there's the X, there's the Y, there's an X, there's a Y, there's an X, there's a Y, there's an X, there's a Y. The 2 goes with the 3. Do I have anything that contradicts that? No. There's a 3 that goes with the 6. Do I have anything that contradicts that? No. A 4 goes with the 6. Do I have anything that contradicts that? No. A 5 goes with the 3. Nothing repeats there. So this is a function. This set of ordered pairs is a function. Lastly, let's look at I. Again, I'm going to label these X and Y. If you're really good at this, you may not need to, but as you're working on it and learning, you will probably want to. It keeps things straight. 2, does anything go to 2 other than a 5? Nope, there's not another 2 telling me something different. Is there another 4? No. Is there another 6? No. Is there another 8? No. So this is a function. Lastly, let's look at the number 16. And it says 4x squared, or excuse me, f of x equals 4x squared minus 3, and asks you to find the following. It asks you to find f of 5 and f of negative 2. And this is our function notation. Basically, it gives a name to this particular function, and its name is f. And in the parentheses, it says we're using x as our input. So it's 4 times the input squared, subtract 3. And so f of 5 simply means that everywhere we see an x, we'll put a 5 in that place. Notice how I went and wrote the equation down and just left a blank, because that's where the input goes. And in this case, instead of writing an x, I'll write and put back in a 5. Then we just use our order of operations to simplify. I can put this in the calculator, and on the exam, if this is a calculator part, you may want to show a little bit of work, because you should be able to do 5 squared. 5 times 5 is 25 minus 3, and then 4 times 25 is 100 minus 3 is 97. But you also want to check this on the calculator. 4 times 5 squared minus 3 is 97, and you really want to be able to do it that quickly. Don't spend a lot of time on it. If you're struggling with the order of operations, get your 97 first so that you're sure where you're headed. The same thing with the f of negative 2. That then means you're going to go 4 times negative 2 squared minus 3. If you're not sure what negative 2 squared is because of the negative, remember it does include the parentheses. It's negative 2 times negative 2, which would give us a positive 4. So that's 4 times 4 minus 3. We do the multiplication first, which would be 16 minus 3, and that would be 13. And just to double check, type in the whole thing, and that should give you then the 13. I'm going to stop here because I did quite a few. I did actually got 3 problems done in this set. So I'm going to stop here to keep these videos short so that you can find the problems that you're looking for that you need to go over. If you need additional help, please feel free to contact me at beth.dixon@ws.edu, and I'll be glad to give you some help. Thank you for watching.